Alright, so now we're on to 13.3, which is solving harder trigs. So this is combining what we've done so far this week. So first of all, we're going to rearrange and do some stuff to this to get it down to one type of trig. Then we're going to solve it, find the principal value, sketch it, find all the equivalent values. So everything's kind of pulled in together. So for this one, first of all, I'm going to try and reduce it to one trig function. So step one, use identities to turn into one trig function. So let's try that. I'm going to times both sides by this and then try and rearrange and simplify. So we get cos 2x plus 0.5 is equal to 2 minus 2 cos 2x. Cool. Now I can add 2 cos 2x to both sides to get 3 cos 2x. Take 0.5 from each side to get 3 over 2. And now I can divide both sides by 3 to get cos 2x equals 1/2. Cool. So now we're at the next step. So this is turned into one of the questions we did in the first lecture this week. So step 2, find range of angles. So we've got 2x, our angle range is from 0 to 270. So we're going to say it's 2x, we need to times these by 2. So we're going to get 540 and 0 times 2. It's still 0. So we've got to solve this cos between 0 and 540. So there's going to be a lot of solutions for this one. And in step 3, find principal value. So you've got to find my principal value. In this case, we're going to do inverse cos by half, which will give me 60 degrees. Now we're going to sketch and find all the equivalent trig to 60 degrees from 0 to 540. So cosine starts at top, down and up. That would be 360, but we need twice that amount. No, we don't. We need 1 and a bit times that amount. So down. Is that going to be it? No. Back up to there, I think. So if we label the axes, we've got 180, 360. Then we're going to get 520 there? Yeah, 540. Yeah, that's it. So 540 there. Cool. So that's our range of values. We know our principal value was 60. So let's put that on here as well. So there's 90, so 60 is probably around here. So I'm going to get a value there and there. And it doesn't look like it's going to be any further value. So just 3 this time. So again, we're measuring from the peak. So from this peak, you're going to have 60 that way and 60 that way. So my angle's 2x, so 2x is going to equal 60 as my first value. 300 takes 60. Sorry, 360 takes 60, which is 300. And 360 plus 60, which is 420. And then we'll divide these by 2 to find our x values. So 30, 150, and 210. If you wanted to check the whole question, put some of those angles in here and here and see if it does equal 2. And then you know you've got 4 marks on a big question like that. So a little bit of everything with these. Next one. So this time we're trying to solve 4 lots of sine squared minus cos when it equals 3 minus 2 cos theta from 0 to theta to 360. Cool. So again, first bit I'm going to try and reduce this down to one type of trig identity. So if we expand this side, so 4 sine squared theta minus 4 cos theta now I'm going to try and get everything on one side. So we'll add 2 cos thetas to each side. So 4 sine squared minus, add that, so 2 cos theta minus 3 equals 0. So it looks a bit like a quadratic. Problem is that we've got a mix of sine and cos, which is not going to be any good. So we need to change this sine into a cos. And the way we're going to do that is using our sine squared plus cos squared equals 1. So I can say sine squared is 1 minus cos squared. So if we drop that in, we're going to say it's 4 logs of 1 minus cos squared theta minus 2 cos theta minus 3 equals 0. If I expand this, we'll get 4 minus 4 cos squared minus 2 cos theta minus 3 equals 0. Almost there now. So 4 take 3 is 1, so you get minus 4 cos squared minus 2 cos minus 1 equals 0. And to make that a bit easier, let's times it by minus 1. So we get 4 cos squared plus 2 cos theta minus 1 equals 0. Cool, so we can factorise that. If you're finding it hard to factorise, put in your calculator, or you could say, if you like it, it's 4x squared plus 2x minus 1 equals 0, where x equals cos theta. Either way you do it, you'll find your principal value is going to be, we get 2 actually for this one. So you get cos theta equals 0.309 or cos theta minus 0.809. So when you solve that quadratic, those are the values you get, which are going to be our 2 cos values. So we need to find what angle those relate to. So if we do cos to minus 1 of 0.309, we get theta equals 72. So that's one of our principal values. And the other one, cos to minus 1 of minus 0.809, gives us theta equals 144. So we've got 2 principal values this time to solve between 0 and 360. So a bit more work at the end of this one. So if I sketch cosine again, from 0 to 360, there we go. Can label in our points, so we've got 360, 180, 0. So we'll start off with 72 and we'll make a big list of all of our angles. So 72, if 90 is here, 72 is going to be about here. So that's measured from the peak. So there should be another one there measured from this peak. So if we do 360, take 72, we get 288. So we got 2 solutions there. So 72 and 288. Our other solutions are going to come from 144. So 144 is here, which we're going to measure. We can measure again from the peak if we like, or we can measure from the bottom there. I think easier to go from the peak, 144. So our corresponding angle is going to be here, which will be 144 that way. So 360, take 144, which is going to be 216. So we get 144 and 216. So 4 solutions for this one. So again, these are quite common. Something that turns into a trig quadratic. 2 solutions, sketch them and find all the relevant values for those. Cool, I think we'll try 2 more of these and that'll be it for today. Cool, so example 3, solve. So solve that for that range values. If you want to pause it and try it, you can. It is quite hard, this one though. So first step is going to be to get all sine and cos on one side. So if I divide both sides by cos, I'll get 5 sine squared theta over cos squared theta equals 4. I can now divide both sides by 5, so I get sine squared over cos squared is 4/5. And sine over cos is tan, so sine squared over cos squared is going to be tan squared equaling 4/5. So if I square root both sides, we're going to get tan theta is plus or minus 2 over root 5. So now we've got to one trig, we can just plot this and try and solve it. So we'll find our principal value next. Or principal values, because there's plus and minus. So tan to the minus 1 of 2 over root 5, which gives us 41.81 degrees. And tan to the minus 1 of minus 2 over root 5, which gives me minus 41.81. So we've just got to find all the equivalent values between minus 180 and 180. So plot my graph for tan. Stop at 180 and stop at minus 180. Cool. Right, so 41, well, if that is 90, 41 is going to be about here, so we should get another value there. And then minus 41 will be about here, which should give us another value there. So this one is 41 from where it crosses, this should be 41 from where it crosses, and that's minus 180. 180. So my theta values, 41.81, and we're also going to get minus 180 plus 41.81, which will be minus 138.2. We're going to get minus 41.81, and the corresponding value to that one is going to be 41.8 away from where it crosses. So 180, take that, which will be just 138.2. So there's my solutions for that table. Right, one more of these. We'll do one that has a transformation in it as well, so quite a bit harder. So for solve so solving this one. Again, it looks like it's going to be seen to a tan because we've got sine and cos mixed together. So if I divide both sides by cos 2 theta, we're going to get 2 sine 2 theta over cos 2 theta equals 1. Divide both sides by 2 to get sine 2 theta over cos 2 theta is a half. Sine over cos is tan, so we're going to get tan 2 theta equals 1/2. Cool, right, next step is to transform the limits. Because we've got 2 theta, our limits apply for 1 theta, so we need to double these. So our new limits are going to be 0 to 2 theta to 720 degrees. Principal value next. So tan to the minus 1 of a half, which is going to give us 26.5 degrees. So we need to find all the equivalent angles to that between 0 and 720, and then half the minimum. So sketch tan. 360, so we need to do that much again. And that's going to be up to 720. So it's a good idea to try and fill everything in. So we're going to get 180, 360, 720, and 540. Good. We'll put our principal value in, so 26.5 is about here. So we're looking for 1, 2, 3, 4 solutions in total. So let's get that ready. So 2 theta is 26.5. So now we just need to find all these other values. So if our first value is measured from where it crosses, all of these are as well. So we're going to add 26.5 to each of these values. So 180 plus that is 206.5. 360 plus that is going to be 386.5. And 450, is it 450? What was it? 540, isn't it? 540 plus that is going to be 566. So last one we need to do is half those, so we get theta is 13.25, 103.25, 193.25, and 283.25. Again, you can check those by putting them right back into the very first equation and seeing if it all works. Cool, right, one more video this week then.